Okay, so we take a look at page 3. It's some examples of how we can actually use these sinusoidal functions. If we take a look at the first one here, we've got the temperature of water off the coast of France, given by this equation. This equation is a cosine, which means it's going to be a periodic function. It's going to look like a wave that goes up and down according to the variety of numbers we have in it, the 3, the 15, the 14. There's been some transformations. And our key here is that t is the number of hours since 6 a.m., kind of our key. That's our starting point. Okay. Part A, I want to find the initial temperature. I want to find the temperature at the initial point. That would be 6 a.m. At that point, no time has gone by. So my temperature can be found by -3 cos of 15 times 0. And I got to figure out what all of this is before I take the cos of that, plus 14. Now, if you have brackets on your calculator, you can punch in the way it looks, or you can do a little bit of math first. -3 times the cos of 0, because 15 times 0 is 0, plus 14. And if you put that in your calculator the way it looks, you'll end up with a temperature of 17 degrees Celsius. That would be our initial temperature. Okay. Part B, temperature at noon. Well, I have to stop and think about, I started at 6 a.m. and now it's noon. How many hours have gone by? That would be 6 hours later. So my temperature now will be given by -3 times the cos of 15 times 6 hours, right? 6 hours later, plus the 14. Sorry about that, Bell. Again, if I simplify this just a little bit, make my life a little bit easier, that's the cos of 90. And I punch that in my calculator the way it looks, and I end up with 14 degrees Celsius. Okay, so it looks like our temperature is going down a little bit. Part C, I want to figure out the period. Now, from the previous page, and the part I told you guys to look over here, we were told that the period is affected by the k value. In particular, the period is 360 divided by k. And k is always the number between your cos and sine and your variable. So k is right here. So if I want to figure out the period of this thing, the period will be 360 divided by k. In our case, k was 15. So 360 divided by 15 comes out to 24. What's that telling us? Well, every 24, and remember our units here is time and hours, so every 24 hours, the cycle, the temperature cycle, repeats. That should make sense, right? Over the course of the day, the temperature goes up, goes down overnight, and comes back up during the daytime. Yeah, it kind of makes sense in a logical fashion, right? All right, part D. Identify the equation of the central axis. What does it mean in terms of the problem? Well, again, we were talking about the central axis, and it said over here the c value moves the graph up and down. And it can also be seen that the c value is the central axis. Because when you move things up and down, you're changing average. You're changing where normal lies. In our case, the c value is right here, the 14. Okay, not the plus 14. And so for us, our central axis, CA, is y equals 14. I don't have to do any math for it. I can see it in the equation. C is my central axis. What does it refer to? Well, this would be the average, because we've always said central axis is your average, right? The average, in this case, we're talking about temperature of the water. And on average, it's 14 degrees Celsius. Sometimes it gets warmer than that. Sometimes it gets colder than that. But on average, it's 14. Okay, and then part E, last part. What's the range of the water temperature? How far does it go? Okay, again, on the last page, we talked about, and I pointed this one out to you guys, the max value can be found by using C plus A, and the min can be found C minus A. And what did I say about that? I said that my max is made up of my average, my C value, plus my change from average, my change from amplitude. What is the amplitude? Amplitude is your A value, the part out here at the front. Now, I'm not going to include the 3, or sorry, the negative sign. The negative sign actually tells me something else. We'll worry about that another day. But the 3 itself is my amplitude. Okay, so 14 plus 3 is 17. My min would be 14 minus 3 would be 11. So to write this as range, I'd say my temperature is always greater than 11, but never higher than 17. And that's how we solve range, using our different properties in the equation. Okay, give the last example a try yourself, see if you can figure all the parts and pieces out, and then following that you can try some of the homework. Okay, the population of water buffalo, given by this equation, I see the word sine, that tells me it's sinusoidal, that's going to make a wave. Okay, where t is the number of years since the first estimate was made. Part A, what was the initial estimate? That's when my time is 0, right? So my population will be 250 times the sine of whatever 90 times 0 is, so obviously 0. And if I want to simplify that, I can, or I can punch it all in my calculator the way it looks. But if I do that, I end up with 400 buffalo, or water buffalo. Okay. What was the population size after 6 months, and again after 2 years? Okay, 6 months. Remember, time is being measured in years. So if I say 6 months, that's not a year. That would be half a year. So I'm using t as 0.5. But after that, it's the exact same equation again, right? 250 sine 90 times 0.5 plus 400 all in your calculator, or 250 sine times 45 plus 400. That will come out to 577 approximately. And again, if I want to do part 2 of this, what's the population after 2 years? Our population will be 250 sine 90 times 2, or 90 times 100, or sorry, 180 there if you want to. That'll be just as quick. And if we do that, we end up with 400 buffalo again. So it went up, and then it came back down. Because remember, initially it was up 400, then went to 577. Okay, part C. Find the smallest and largest populations that were reached. In other words, let's find the range. Okay, so our max is our C value, our average value. Well, that's 400. Plus our amplitude. That's our A value, right? It went up by 250. That gives us a total of 650. There's our max. Our min, our average was 400. Our amplitude was 250. If I subtract that, I get 150. So we can say our population was always, we'll call this P for population. That's what they were giving us. Between 150 and 650. Okay, never went higher or lower than that. Okay, part D. We want to know about the period. What does it mean in terms of the problem? So we've said our equation is period equals 360 divided by k. K is a number between the word sine or cos and your variable. So this is k. And this was A and this was C, right? Okay, so I got to take 360 and divide it by k. So in our case, 360 divided by 90 gives us 4. What does that mean? Well, every 4, and remember our variable was time and it was measured in years, so every 4 years the cycle repeats. Okay, so our population goes up, goes back down, goes lower, and recovers again. So something's going on there to make this population do that. Okay, part E. Last one. What would the central axis mean here? Well, we've already talked about that, but just to point out one more time, central axis, y equals the C value, the part at the end there, 400. And the key here, remember, is the central axis refers to average. So the average population of buffalo is 400. Okay. And that's the end of sinusoidal functions. Again, your homework takes a little sheet. I think there's 3 questions on it. Give them a try, check out the answers, and then try the quiz today, I think.